This is LeetCode problem 15 called 3-sum, a medium level problem. You're given an input array of integers, negative and positive. You need to find all the unique combinations of 3 digits that results in the value of 0. We're going to go over the top voted solution in Python over in VS Code. Just give me a moment here to switch over. So they started off just creating an empty container with your return values called res, and then they're going to sort their list. And this is important just to understand that if you're going to use the two-pointer methodology, you need to have a sorted list. Their overarching outer looping mechanism for I is going to iterate through all index positions, and this line of code is going to check against duplicate values at the i's index position and just skip over them to save on processing time. If a unique value for index position of I on nums is found, then it's going to create j as one index position to the right or one index position greater than I, and then it's going to set the k index position at the last index position. And then the inner loop here is going to iterate through all possible combinations of j, k with this one static I index value until it either gets a result or finds that j equals k, and then it's going to go spit it back out and then go to the next iteration of the I for loop. And what's unique here, at each iteration of this while loop, it's going to create the sum. If the sum is greater than 0, it's going to index k downward. It's going to index it to the left or increment it to the left, and then if the total is less than 0, it's going to increment j to the right. If it ends up being 0, the total, then it's going to add that combination to your resultant array, and then it's going to increment j to the next position. Here it's just going to skip over any duplicate values that are found for that j index position. Why it makes sense to, or why it's necessary to sort the array is basically that just allows this mechanism to work, where you're going to increment it one direction if your value is greater than what you want, and one direction if the value is lower than what you want. And in an assorted array, that makes sense because imagine here that I is 0, j is at the 1 position, and k is at the 2. Let's just imagine we wanted the value of the sum to increase. What we could do is increase the position of j, because we know that as it goes to the right towards k, it's going to be increasing in value. And then the same goes for if we need to reduce the value of the total, is we can just increment k downward closer to j, and the values should decrease. If we had the same values in an unsorted list, this wouldn't be possible. You just have to do all possible combinations and sort through them all. So it just doesn't save on processing time at the end. So let's step through this a little bit in the Python debugger just to give you a better visualization here. So just note here in the upper left the windows where you can see the current values of I, j, and k. The sorted array now nums, what's being added to the result, and then you have just the values at these positions here so you can get a visual. So essentially now you have the total is -3, that's going to be less than 0, and so it's going to move that j index position 1 to the right. And as we can see now, the total has increased in value by that difference in j. And what it's going to do is continually step j over until it either finds k or you have the result you want. And when it finds the result you want, you're going to still want to continue to iterate through all of those possible pairs, and so then you're just going to step j over once and then continue the iterations. And then what that allows you to do, because it's skipping over any duplicates of j and skipping over any duplicates of I, it really avoids any potential for there being duplicates in that result bin. So this was the top voted solution, LeetCode problem 15. This is Grover with Blue Collar Codes. Thanks for joining.